Well, good afternoon, good evening, friends, colleagues, students, distinguished guests. Here, and is this being live streamed as well?
Yes.
Yes. Well, welcome also to our guests who are online. I'm Professor Diaredi, Interim Vice Chancellor at the University of Cape Town, and it's my real pleasure to welcome you all to this UCT inaugural lecture, which will be presented by Professor Elizabeth Mayne, about whom we'll hear more shortly. Elizabeth is the head of the Division of Immunology in the Health Sciences faculty and the chair of the Immunology Expert Chairs Committee for the National Health Laboratory Service. I'd like to welcome very warmly, especially members of Elizabeth's family, who I think are all seated in the front row. Great to have you here. It's a wonderful occasion, and wonderful also that you're here to participate and celebrate with us. Allow me to introduce the platform party for this evening's event. So we have on my immediate right Professor Kamal Pillay, who's the head of the Department of Pathology in the Faculty of Health Sciences, and who will introduce Professor Mayne. And then on her right, rather, we have our speaker this evening. And on her right, we have Professor Lionel Green-Thompson, who's the Dean of the Faculty of Health Sciences, and Lionel will later on deliver the vote of thanks. So, colleagues and ladies and gentlemen, the UCT inaugural lectures, well, I should say inaugural lectures generally, are special events in the academic life of a university and something of a rite of passage for our academic staff. The process, whether one is appointed to the rank of full professor or achieves that rank by promotion, either way, the process, the path is an arduous one. It's very tough to get there. And so it warrants, at least for that reason, a special place in our calendar. Excuse me. So, you know, we in university, of course, we engage in teaching and in research and social responsiveness. And we exercise various freedoms that we have as academics, freedom of expression, etc., communication, association. But with those freedoms come academic responsibilities. And one of those is the responsibility to share one's research and to share it in particular with those for whom it may be of use. This ties in very directly with the guiding mission of UCT as expressed in our Vision 2030 strategic document, namely to unleash human potential for a fair and a just society. So the Division of Immunology, which Professor Mayne leads, fulfills this mission in various ways. The division addresses a range of diseases with particular focus on conditions that are relevant to Africa, such as HIV/AIDS, tuberculosis, leishmaniasis, listeria, and helminths. Infections with a high rate of morbidity and of mortality in humans. The division also addresses the need for capacity building and capacity strengthening across the African continent. Students come here from all over Africa, as well as from other parts of the world. And many research projects are collaborations with colleagues in other countries. And these lay the groundwork for professional cross-training programs with partner laboratories here and elsewhere. And this too is such a central component of successful research, I should say. Over and above it being a responsibility, the importance of collaboration and coming back to UCT's vision, particularly across the continent of Africa. And here we have some very good evidence of that. So by serving the continent with innovations from around the world, and by providing a platform for African innovations to have an influence elsewhere in the world, the Division of Immunology is well on its way to fulfilling its goal, not only of unleashing human potential in line with UCT's vision, but also becoming the center of immunology research in Africa. So with those few words of welcome, ladies and gentlemen, I'd like to invite Professor Pillay now to introduce our speaker. Thank you.
Thank you, Vice-Chancellor. Good evening to all present here and online. It is my great pleasure to introduce Professor Elizabeth Mayne. Elizabeth matriculated with distinction from the St. Andrew's School for Girls in 1996. She studied medicine at Wits and received numerous awards, including University Merit Scholarships and a prize in cell and molecular biology. She was an intern at Universitas in Bloemfontein and did her community service at Metsi-Maholo District Hospital in 2004. Prof Mayne completed her hematology training at Wits with numerous awards. She received the Center for AIDS Research International Scholarships in 2006 and 2008, and was the top student in the FC-PATH exam in hematology in 2009. She also received the CMSA Phyllis Knocker-Bradlow Award in 2012, and in 2013, the Discovery Award for Academic Excellence. She then progressed to becoming a principal hematologist and head of Department of Immunology at Wits, where she is an ongoing associate professor. In 2018, she was also the National Health Laboratory Services Acting Executive Manager for Academic Affairs, Research, and Quality Assurance. She is the current chair of the Immunology Expert Committee and the chair of the Chairs Expert Committee. In the last year, Elizabeth obtained a PhD from Wits with a fellowship from the Royal College of Pathology in Immunology, two qualifications which are both phenomenal achievements while being professor and head of immunology at UCT. She has established 3 key research areas and has published and received grant funding towards each. These include basic and translational immunology, diagnostic and applied immunology, as well as the establishment and maintenance of a faculty biorepository. She has also spearheaded some initiatives to coordinate teaching of registrars nationally, including coordinating an examathon and establishing the immunology course. Her undergraduate vision for teaching is to make education a transformative experience that empowers all students to develop capacity for lateral thinking, problem solving, and continuous learning. She is an excellent undergraduate lecturer, as evidenced by the students that are attending her lecture today, and also highly rated and productive as a postgraduate supervisor with glowing reviews all around. One of her students says, "What truly sets Prof Mayne apart is her commitment to holistic learning. One aspect that stood out with Prof Mayne was her dedication to fostering my growth in research." I was fortunate enough to get some background from Elizabeth's closest family members that are here. From her dad, Tony, Elizabeth Sarah Mayne, or Libby, as we know her, was a hyperactive child and exhausted her mother's stamina. So when she was 5, her father took her to a symphony concert featuring Saint-Saëns Organ Symphony, expecting to tire her out and give her poor mother a rest. The outcome was a transfer of her mother's exhaustion to her father, because she sat with eyes as wide as saucers and demanded she be taken to all future concerts. This has continued, with her poor father having to take her to somewhat out of the ordinary works, like Shostakovich's Lady Macbeth of Mtsensk in London and Wagner's Ring Cycle in Beirut. For matric exams, her staple was the swinging Mozart's Requiem, which drove everyone to distraction. Libby departed from this routine by doing her BA Honours, which was achieved with distinction, in Middle Eastern Studies and Egyptology, at the same time as studying for her fellowship exams in haematology. This led to her learning Arabic and cuneiform and ordering the family to accompany her to Egypt and Jordan. From her mum, Susan, Elizabeth marches to a different drum and is given to eccentricities. She was a totally insomniac baby and toddler, and soon proved to my friends that her efforts to child-proof their houses were laughable. By the time she was 3, she had mastered Yale locks and found high, unreachable medicine cabinets a source of endless fascination. Trying to stay one step ahead of her was a huge challenge. We are immensely proud of all her academic achievements, but I am even prouder of her ability to walk 2 moons in the other person's moccasins. She tries to be fair, and she's unfailingly kind and forgiving. From her husband, Paul, on behalf of himself and their daughter, Rebecca, Elizabeth is a person who wears a multitude of hats across her personal and professional lives, from her multiple roles in her work sphere to doting mother, responsible daughter, amateur cupcake baker, aspiring cake decorator, frustrated travel agent, competitive knitter and crochet blanket maker in her home sphere. The ease with which she slips into each of these demanding, and in the case of cake decorating, ability-challenging roles makes one envious, as well as curious as to how she is able to compartmentalize all of this and remain relatively sane. Elizabeth also has a strong sense of what is right and what is fair, and is prepared to stand up for those ideals with a resourcefulness and tenacity that her outward appearance belies. She is both an amazing ally and a formidable opponent. This core of iron fortitude is something that Elizabeth has called upon through the challenges she has faced. And with those endearing words, I now hand over to Professor Elizabeth Mayne to present her talk titled Racing the Red Queen. Thank you.
Thank you very much, Professor Pillay, for those very kind words, and for my family for giving you quite so many anecdotes about my youth. Hopefully, I've outgrown the hyperactivity in the meantime. So I have quite a few students in the audience, and students will know that I always talk in analogies and stories. So that's how I see the world. Maybe that's part of my African roots, is that I'm a storyteller, and all good stories start with a topic or with a title, and so I chose this topic. But maybe as important as the topic that I did choose is the one that I rejected. And the one that I rejected was this one, which is my own worst enemy or adventures of an immunopath, because as much as I love immunology, my immune system doesn't love me quite so much back. So I come from a long line of immunologically challenged individuals. And this includes, for example, my aunt who has very severe rheumatoid arthritis, and hopefully she's online listening to this at the moment. A number of my cousins have severe Crohn's disease, and then I had very severe asthma, or continue to have very severe asthma. So maybe this is one of the reasons why I felt compelled to look into this particular topic, because it seems to me amazing that such a family could exist and continue to thrive in a world despite these challenges. But eventually I chose this title, not only because The Red Queen is one of my favorite books, which is Through the Looking Glass, and what Alice found there, but because immunology really is encapsulated by the Red Queen. So the actual quote from that book is, "Well, in our country," said Alice, still panting a little, "you generally get to somewhere else if you ran very fast for a long time, as we've been doing. A slow sort of country," said the Queen. "Now here, you see, it takes all the running you can do to keep in the same place. If you want to get somewhere else, you must run at least twice as fast as that." And that encapsulates how the immune system works, because it's constantly having to encounter a number of different challenges, from new pathogens to other environmental stimuli. But it does make it quite difficult to be a good lecturer in immunology as well, because you teach somebody something one year and next year it's changed completely, and you start to sound like an idiot. And I always say to my medical students that lymphocytes, they used to believe, sort of the turn of the century, not this century, the previous one, that lymphocytes were like the appendix, that eventually we'd evolved to get rid of the lymphocyte altogether because it was so boring. And now we've realized that maybe it's not quite that boring after all. Okay, so this is from another book that I really enjoyed, which is The Hitchhiker's Guide to the Galaxy. And in this, Douglas Adams says there are three problems, or at least there are a number of problems connected with life, of which some of the most popular are: why are people born? Why do they die? And why do they want to spend so much of the intervening time wearing digital watches? And the answers are immunology, and probably they're doing immunological experiments. Now we know, and this has become increasingly apparent, and I've made these very small intentionally so that you don't get distracted by the fancy titles, but we now know that the immune system plays a pivotal role in the entire course of a human's existence. This starts off with love and desire. So you might think it's because somebody is kind and generous and beautiful that you fall in love with them, but actually, as I say, it's because of your immune system. The immune system governs implantation of the fetus. Birth, labor and birth is actually an immunological process. It's rejection of the fetus by the mother. It governs how we survive childhood. It governs how we survive adulthood. It's what makes us old. And there are no geneticists here, so I can say, well, genetics, everybody talks about telomeres, but actually it's the immune system. And then eventually the immune system is what is going to kill you off in the end. So throughout our entire lifespan, the immune system is fundamental to what happens to us. And really, there is no part of this process that you can't do research in, that you can't investigate further. If we look at why people die in South Africa, and these are the 2018 statistics published by Stats SA, what continues to challenge us as South Africans is a number of communicable diseases. And you see that tuberculosis, and I'm going to have a shout out to Tom, you see tuberculosis is still top of the pops there. But you can also see there's some other things that are starting to creep up in the meantime, things that are not communicable. And they're starting to overtake what we classically thought of as the scourge of South Africa, which is HIV infection. And as we see this transition from communicable to non-communicable diseases, it becomes increasingly important for us to think about what the fundamentals underlying those non-communicable diseases are. And I'd just like to say that you see for the first time, and this hasn't been in the top 10 until quite recently, we're starting to see cancer is also starting to creep up as well, with a number of South Africans dying from malignant neoplasms of predominantly the colorectal system. Okay, so my research was really started off by a published paper, and it was the results of a study called the Strategies for Management of Antiretroviral Therapy. So that was summarized, and I always say if you're applying for NIH funding, it's always good to have a nice, catchy title. This was the SMART study, but I think we rechristened it the Not So Smart study. So what it was looking at was CD4 count guided interruption of antiretroviral therapy. So just to explain what happened briefly, what at that time, and anybody who had to take post-exposure prophylaxis can attest to this, antiretroviral therapy was very toxic. People didn't want to take it. So the idea was that you would use the CD4 T cell count to guide how you gave antiretroviral therapy. There was one wing where they continued to receive antiretroviral therapy irrespective of the CD4 count, and then there was one in which they would only receive therapy after their CD4 count dropped below 250, and when it rose above 350, they stopped the drug again. Now, this is directly from this article published in 2006, and what they found was in the individuals where the antiretroviral therapy was interrupted, they died. But they didn't die of opportunistic infection. They died of non-communicable complications, of which probably the most important was cardiovascular complications. An editorial was published in the same journal edition by the New England Journal of Medicine, where they immediately recognized that interrupting antiretroviral therapy was extremely toxic, and that was one of the fundamental precepts that we should now continue to treat patients with antiretroviral therapy. Now, just to contextualize that in South Africa, and this is a review that was published by Linda Gale Becker and Francois Venter, my friend Francois Venter, we weren't giving antiretroviral therapy at all at that point. So our program really started off in 2008. So studies across the world were looking at how you manage antiretroviral therapy, and we were just hoping we could get some of the babies and mothers onto the PMTCT, or Prevention of Mother-to-Child Transmission program. And honestly, that was when I was an intern and then in ComServe. And for any of you who did your work at COFC and specifically at Pelanomi, we had these patients called stretcher patients who would be wheeled into casualty with a whole bag full of vitamin B co and cotrimoxazole Bactrim. And we couldn't give them anything because there wasn't any antiretrovirals to give them. So we give them more vitamin B co, and they would come back the next day because obviously vitamin B doesn't treat HIV. And that was actually a completely and utterly soul-destroying experience. Eventually they stopped coming, and you knew at that stage that those patients had passed away. So it was with a lot of reluctance that I stayed in medicine at all, actually, by that point. I really wanted to leave medicine because it felt to me like I was just a glorified clerk. But I then started in pathology, and I had always loved immunology as an undergrad, and I found a system that was quite similar, and was the coagulation system, or how you clot. And this is just a very brief summary. Actually, it's simplistic to the point of incorrectness, but effectively what happens is you have trauma, and that interrupts the vascular wall. You then have platelets, small subcellular fragments, which fill that as a clot. That forms a surface on which the coagulation cascade is activated, and eventually you have the defect is now closed off. And this is a very important process, but like immunology, like all immunological processes, it's very complex. So we'll talk about that just now. Now, this is how we classically think, and this is just what I've indicated, is that you have these cells here, these endothelial cells. These line the walls of the vessels, They start to upregulate these adhesion markers like P-selectin, platelet selectin, as well as this molecule called tissue factor. And tissue factor really then initiates the coagulation cascade by activating factor 7. Eventually, what happens is you activate this very crucial molecule called thrombin, and thrombin converts fibrinogen here. It looks quite pretty. It doesn't look like that in real life, but it's pretty here, into fibrin. And fibrin forms this network, which then acts as a net to catch more platelets and red blood cells and white blood cells. And that's how we think when you cut yourself, when you start to bleed, that's how you stop bleeding. My husband's an anaesthetist. He'll tell you that all bleeding stops eventually. But this is the right way to do it. All right. So the endothelium is a monolayer of cells, but the important thing about the endothelium is, just like the lymphocytes we thought were so boring, the endothelium is this very boring, flat layer of cells. But it turns out that not only do they help regulate how you clot, but they also regulate inflammation as well. So as the endothelium becomes activated, as those adhesion molecules get expressed, the white blood cells start to move from the circulation into the tissue. Now, in lower order species, and I'm always slightly reluctant to say lower order species because I actually like a lot of lower order species, but in invertebrates, actually the immune system and the coagulation system are the same system, and they have actually one type of cell that has both functions, both coagulation and an immune function, and they're called amoebocytes. And the amoebocytes come, they sort of surround a pathogen, a bug that's got into the cell, and then they start to kill it off. And so it suggests that coagulation maybe is a critical component of our immune response. Okay, and it makes sense even in us that we would clot to keep the bug from moving throughout the entire body. This is a horseshoe crab, which I had to put in because it's so cute. Okay, and it's going to move. Yes, it does. All right. So in horseshoe crabs, we have these amoebocytes. Now, coming back to the SMART study. So the SMART study, as I mentioned, showed that what killed patients who had interrupted antiretroviral therapy was cardiovascular disease. And the two predictive molecules which indicated that those patients were not going to do so well was the D-dimer and interleukin-6. Now, interleukin-6 is a cytokine, so it's secreted by white blood cells, and it forms part of the immune response. D-dimer is a breakdown product of the clot. So again, we're saying patients with HIV, it looks like there's inflammation happening, and then there's also coagulation happening, and those things possibly are what is causing the problem in these patients. So what is sitting between coagulation and inflammation is this layer of endothelial cells, and this is another picture that I love. It's a Creative Commons download, but you can see this little T cell, so a white blood cell. It's attached to this little endothelial cell, the blue one. They're not blue in real life, it's been colored, but that T cell is getting ready to move into the tissue. So it makes sense that coagulation would work as an innate immune response, but what about the opposite? Is the immune response a coagulation event? So this is where I introduce yet another cell, and I'm sorry, immunologists love cells and abbreviations and jargon. Those are the three things we love. So if we can get them, all three of them, into the same sentence, that makes us very happy. So monocytes are a type of white blood cell, or leukocyte, and they're made in the bone marrow. They're probably one of the most important cells of the innate immune response. The important thing is that they interact with the CD4 T cell. And the CD4 T cell is the big kahuna, the big boss of the adaptive immune response. And they have a very special relationship with the CD4 T cell because they express a molecule called MHC. I'm asking my second row people. MHC. MHC class 2, correct. So they're professional, sorry. What can I say? I'm a pedagogue. I can't do it. All right. So they're professional antigen presenting cells, and they interact with CD4 T cells in the structure called the immunological synapse. The other important thing is, although everybody will tell you that CD4 T cells are a target cell for HIV, so are monocytes. Monocytes also express CD4, can also be infected with HIV as well. So this has taken a long time for me to get to this point. So this is work that I did very shortly after that paper was published in NEJM. In fact, in 2006, I was a first-year registrar, and we said, well, let's look at this relationship between monocytes and clotting. So we know that platelets cause clotting. We know the endothelium causes clotting. Do white blood cells cause clotting as well? And the answer was yes. And I've put two very important people, and I'm hoping they're also online, Professor Michael Lederman and Professor Nicholas van der Berg, who are both in the States. And they gave me a desk and a pipette, and they said, go wild. So I went a little bit wild. Now, the expression of tissue factor in monocytes in patients living or people living with HIV correlates with the viral load, inversely with the CD4 T cell count, albeit weakly, with markers of immune activation, with markers of microbial translocation, and with the D-dimer levels. So although this doesn't prove that monocytes are the instrumental cell of coagulation, it certainly appears to be that those monocytes were becoming involved in clotting in people with HIV. And was this part of the answer as to why patients with HIV were dying of cardiovascular disease? So our classical thinking about coagulation is that there are two main cells, the platelets and endothelial cells, both express tissue factor, and that's what causes you to clot. But wait, and monocytes. So, sorry, there are three main cells that affect coagulation, platelets, endothelial cells, and monocytes, macrophages. And then possibly no, there's another cell as well. So again, it was starting to appear that coagulation, like any process in the immune system, had a lot of subtext in it, a lot of extra pathways. So following that work, we then looked at the relationship between monocytes and platelets in patients living with HIV. And what we found is that the monocytes and platelets were actually interacting directly with each other. Not only were they reciprocally upregulating tissue factor, but the platelets were becoming activated. And those platelets were becoming sticky, and that stickiness was associated with increased risk of clotting. And eventually, the platelets and monocytes got together and formed microparticles. And those microparticles then were effectors of coagulation on their own. So the tissue factor on monocytes correlates with the tissue factor expression by platelets. Platelets taken straight out of patients with HIV infection are already activated, and they're getting ready to clot. And the platelets and monocytes start to fragment and form these little microparticles, which are highly, highly reactive when it comes to coagulation. And again, this platelet activation is related to immune activation, microbial translocation, suggesting that this was a fundamental mechanism underlying coagulation in HIV. Now, we've continued to do this work on HIV-associated cardiovascular disease and biomarkers, but really every time you answer a question in science, that tends to result in at least 4 other questions, and you just have to find a way of answering them. And doing in vitro studies can only take you so far, and biomarkers are biomarkers. It used to be that a gene is what you knock out of a mouse to create a paper. A biomarker is what you get out of a human to create another paper. So the SMART study, and this is taken by a paper that I published with a friend of mine, the SMART study immediately triggered 3 million additional studies on cardiovascular disease in HIV infection. Importantly, the minority of these are in South Africa. They're predominantly in patients outside Africa in general, but outside South Africa. Again, replicating the finding that monocytes and the immune system appears to be linked with this concept of immune coagulation. And again, something that we're starting to see. So did that actually mean anything? And certainly the epidemiology was becoming clearer in South Africa as well. Again, some of these are now coming out of the South African population, saying that people living with HIV have up to a 10-fold increased risk of venous thromboembolic disease. There are 2,856 papers as of Monday. What's today? Monday. As of today, that look at cardiovascular disease in patients with HIV infection, and this includes everything from macrovascular disease, myocardial infarction, as well as cerebrovascular accidents. And this was a terrifying paper, and this was published last week, where they said that atherosclerotic cardiovascular disease, including myocardial infarction, stroke, and cardiomyopathy, is now the major cause of death in HIV-infected, HIV-positive individuals. The global burden of HIV-associated cardiovascular disease is tripled. And what does that mean for us in South Africa? Now, in South Africa, we have all of those problems, but a little bit more as well. And we don't know why. And this is something where I would challenge the researchers to look a little bit closely. So in many ways, we show similarities with what we're seeing in other low and middle income countries, but our patients predominantly, or at least a large percentage of our populations actually present with peripheral vascular disease as opposed to myocardial infarction. And we have these weird microvascular complications as well. Now, just to say that we've been collecting a cohort of people with HIV and peripheral vascular disease, and these patients present on average about almost 20 years younger, and with fewer other conventional risk factors for macrovascular disease. And as I mentioned, we're now starting to look at how these are probably being linked to neutrophils, another innate immune cell. But as I say, we seem to be seeing a lot of microvascular disease. Now, one of them is this syndrome known as disseminated intravascular coagulation. And what happens in those patients is that they make clots throughout the body. So tiny little clots throughout the body. Eventually, it uses up all the platelets and all of the coagulation factors, and then those patients start to bleed catastrophically. All right, high mortality in those patients, and we're seeing a lot of those patients as well. Now, this was one of the studies where we looked at causes of disseminated intravascular coagulation in large cohorts of patients. And again, we seem to be seeing that HIV has one of the highest relative risk ratios for development of DIC. And that these patients, again, have very different characteristics when you compare them to patients with other causes of DIC, like malignancy. The other important thing, and here I have to have a shout out to my recently qualified PhD student, Dr. Susan Lowe, is that we developed this other microvascular complication called thrombotic thrombocytopenic purpura, or TTP. In TTP, the endothelium starts to release huge procoagulant molecules into the circulation. And again, these patients develop these microvascular clots throughout the body. Eventually, those clots physically obstruct the blood flow, and as the red blood cells try to move past them, they get actually physically damaged into fragments. They have very low platelet counts, and if they're not treated, and the treatment is plasma exchange, and it's very expensive, very invasive, and not always successful, although in the majority of cases it is. If they're not treated, they often die of either end organ complications like renal disease or severe anemia and very low platelet count. TTP, when I was a haematology registrar at the very beginning, TTP was one of those things that you learnt if you wanted to get a first in your exam. Now TTP is something which, if you don't know, you're going to fail your exam altogether. So again, we're seeing this massive increase in South African patients, and in some cases it does not seem to be linked to antiretroviral therapy. And again, it's going to be so important for us to have some kind of understanding as to where it's coming from. So where did we come from? Where are we going? So as I said, if you consider coagulation as an innate immune response, then HIV is going to have an effect on that, as it does have effects throughout the immune system. And it suggests that already the blurred vision or the blurred boundaries between communicable and non-communicable diseases are becoming increasingly blurry. And this is going to be something that we have to look at increasingly as we move forward. And so that picture that I showed you that looked complicated is starting to look even more complicated. Lots and lots and lots of people are getting involved now in clotting. Platelets, monocytes, neutrophils, microparticles, different coagulation factors, and they're all coming to the party and probably having an impact on how these patients present. Okay, so that was some highlights from my research career. But as I said, that's what got me to this point. And immunology is why you get to listen to me as well, because you're still alive, which is why I have to now step on to my soapbox. All right, and I'm going to have a little bit of a party political advocacy session now. I showed you this before, and I said, look, non-communicable diseases are becoming increasingly prominent in South Africa, and we're not looking at those conditions. Funding is primarily going to communicable diseases. A lot of our external funding is going to communicable diseases. And we're going to be hitting a brick wall at some point because patients are going to be treated with HIV. They're going to have a TB vaccine. And then we're going to be left with what is underlying our patient population in South Africa. You might, I don't know if you know this book. This was a book which won the Pulitzer Prize. It's by a historian called Jared Diamond, and he said that the difference in society, or the difference between different communities and societies, and whether they were successful enough or not, came down to technology and germs. All right, so the rise and fall of society is attributable to the local microenvironment that we encounter. I showed you at the beginning how important immunology is to the entire lifespan. So you've heard that I'm quite interested in ancient history. So let's think about immunology through the ages. So we think that Homo sapiens arose approximately 200,000 years ago, and our first big city was Catalhoyuk, and that's in Turkey in about 5,700. Then we go through a number of different civilizations, and if we talk about, and this might be somewhat controversial, but if we say that this is the century, or this is the millennium of globalization, what got us there for the last 199,000 years is our own immune systems. And really, immunology is the most social of the social sciences. You can't have a society if you don't have an immune system. All of our most effective interventions are immunological. Vaccination, immunotherapy into the future. This is going to be what keeps us alive as a species, and maybe that we'll be able to overcome the next pandemic as it comes along, and future immunological challenges. We are here, and really we need to be thinking about where we go from here. And if we want to go to Mars, if we want to be healthy and happy Africans, South Africans, we need to be thinking about the immune system into the future. So this is a trope that a lot of people say, you know, if you have a whole lot of blind people and they get to look at an elephant, then that's how they'll describe the elephant, because they only see one small component. And unfortunately, immunology has become that kind of elephant, in that people tend to focus on just one small component without having the global overview. Or this is the other elephant that it could become, with people taking one small component of immunology away from the greater whole. We need to put that elephant back together, because unless we understand the elephant, we're not going to be able to keep our society and our people healthy. So we need more undergraduate immunology, all right? More postgraduate immunology, more immunologists generally, more clinical immunologists, more immunopathologists. So I started off with a question from The Hitchhiker's Guide to the Galaxy, and this was the answer that was given in that book. All right, said Deep Thought. The answer to the great question of life, the universe, and everything is, said Deep Thought and paused, is 42, said Deep Thought with infinite majesty and calm. Now, that is not the answer. The answer was, as I said at the beginning of the lecture, immunology. That is the answer to life, the universe, and everything. So I'm hoping that I have inspired you with some of the vision that I have, because I believe that there are people who said, you're coming down to Cape Town because of the sea, or you're coming down to Cape Town because of the mountain. And I'm saying now, I came down for neither of them. I want to put an elephant between the sea and the mountain. And that elephant's going to be an integrated immunology curriculum. Is that impossible? Alice laughed. There's no use trying, she said. One can't believe impossible things. I dare say you haven't had much practice, said the Queen. When I was your age, I always did it for half an hour a day. Why, sometimes I've believed as many as six impossible things before breakfast. So I'm just asking you to believe one, and it's before dinner. So I think that's quite reasonable. Now, there are a whole lot of people, and I know there's going to be a vote of thanks, but there are a whole lot of people that I would like to acknowledge who've really helped me along my journey. The one who unfortunately wasn't able to be here today is Professor Wendy Stevens. She was my head of Department of Haematology. It was her who shared my crazy dream of being an immunologist. She made it possible for me to travel. She actually persuaded me to do haematology when I'd actually applied to do microbiology, and the NHLS HR had made a mistake. So I got sent to the haematologist for an interview. And there she is. And then my other great mentor, who I'm hoping is online now, is Professor Lederman, who, as I say, gave me a bench and a pipette and access to his credit card and said, do something. And then we did something. And Professor Nicholas Vanderberg, who was my partner in crime for some of those early papers. I've already mentioned Dr. Susan Lowe. She was on my very first paper, and she was on my very most recent paper as well. Catherine, another one of my great PhD students, and Dr. Tracy Wiggle, who's now recently moved to Stellenbosch. Dr. Chetty from the NHLS, who also is prepared to listen to me talking rubbish. And then so many people, and I'm sure that there are people that I have left off this list, but if I have left you off, it's with love and great thanks. And then just to say that all students have always taught me much more than I've ever been able to teach any of my students. So I'm really grateful for allowing me into your minds, even for just a few lectures a year. And then just to say thank you to my family, my mom, who I hope taught me integrity and work ethic, my father, who's been a collaborator with me ever since my first Standard 2 project, which I think was mammals, maybe. My aunt and uncle and my aunts and uncles across, and my cousin Matthew came here, and he's still smiling, so hopefully he's still here with me. And then just to say that they say it takes a village to raise a child. Well, it takes a village to allow me to come from Johannesburg, commute from Johannesburg to come and join you here at UCT. So I thank them very much for for making this a reality for me, and to UCT for letting me talk nonsense for 40 minutes. And then just to say thank you very much to my husband, Paul, who's given up having a full-time wife, and my daughter, Rebecca, who's given up having a full-time mom so that I could be here. And as with all of my work, just to acknowledge my sister who died 20 years ago. And thank you.
Kaisekai Gangans. That's become the way I say thank you when I'm particularly moved by a particular moment, because the original peoples in this area had grades of saying thank you. It was Gangans or Kaisekai Gangans, which is their higher form of thanks. So thank you very much for an incredible time with you this evening. Elizabeth, I'm quite struck that, in fact, our first real encounter must have been around 2009 or 2010. But I must say your soapbox has become a whole lot more elegant than it was on that occasion, when you were really literally berating me together with Clive Gray for the fact that there was so little immunology in the undergraduate curriculum. I think you changed that after I left at Wits, and I think there's a whole lot more immunology in that program now. But thanks very much for keeping the spirit of soapboxing, because isn't that what scholars are for? If we cannot identify the problems in our world and then apply our minds to that, what is the point of study? And I think you've given us a very elegant and soft-hearted discourse of, what did you call it, nonsense for 40 minutes. But nonsense which appears to underpin our very existence as a species. So I'm really grateful to that. I want to just start by saying thank you to Paul and Rebecca and Tony and Susan and Matthew for joining us this evening. It's always a particular gift when families are able to join an evening such as this, because we recognize that particularly in this engagement, the absolute sacrifice that families give for our scholars to achieve the things that they do. And so thank you very much to you for the gift that Elizabeth has become to UCT. I'm also remembering that in that conversation, I don't think either of us ever dreamed that we would be at UCT on that occasion. We were still busy fixing Wits. So maybe we'll fix UCT after all. But I mean, I'm really grateful for the comparison you gave to an almost allegorical tale of Alice in Wonderland, and this idea that if we don't allow our scholarship to enter a space of wonderment, then we're less because of that. And I really, for me, in what you said today, I was reminded that immunology is really the story of our age. And I think in the pandemic recently passed, it really was quite nice to have an inaugural with no mention of the pandemic at all. But with this pandemic just passed, I think immunology became a part of everybody's discourse, even those troublesome people who didn't think it was real at all. But I think there's this idea that you brought for us, and I'm really grateful for, is this idea that you captured immunology as a story from our origin into a global idea. And the story from this conception to death idea of immunology, I thought was a really incredible example. I'm in the category of people who says all bleeding stops eventually. And it was particularly enthralling for me as an anesthetic registrar. The thing we struggled most with, or we spoke most about as we prepared for the primary exams, was the coagulation cascade. And somebody always found something that had just come out that changed the way the coagulation cascade worked. So it resonated with me, because I'm still very much in that category of, yeah, all bleeding will stop eventually. What causes it and how it's modulated, yeah, we'll learn about that on the way. But I do want to celebrate your letting us into your story of your own relationship with immunology, this idea of cells, abbreviations, and jargon. I think that was my experience from my deep undergraduate years. There were a whole lot of letters in the immunology curriculum all of the time. But I want to just respond in part in this with the sense of gratitude that what you've done this evening is been able to take a basic biomedical science, link it to our civilization, and then argue that it's integral to how we understand all of the movement of health and disease as we go forward as a community. And so the conversation of an integrated immunology curriculum, I think, is timeless, because we're in the middle of talking about a curricular transformation here. And we've got to hear your conversation so that we make sure that we don't veer too much to one side. In the pendulums that curricular modifications often take, there's often the swing from one way to the other. But let me close this thanks by just saying thank you to responding to the call to UCT. When your name popped up as on the short list of candidates for this post, it was really with quite a great surprise that I saw your name amongst them. And then quite a sense of excitement that you were choosing to come here, recognizing that you were coming into a different place, because I think all of what you had done before was adverts. But I also, in listening to you today, recognize that that moment in that selection itself was a point of gift. And just listening to you today and hearing the story of your many studies, I wondered if this is the beginning of the return of the polymath. But thank you very much.
Thank you very much, Lionel. So, ladies and gentlemen, we've had a tour de force from our inaugural lecturer. We've certainly had the opportunity to hear what it is that the professor professes. She's done so in a way that has truly been accessible, in spite of the jargon, which she went very lightly on, and with some good doses of gentle humor. We've also seen, or experienced, I should say, science at work. During the pandemic, I think to a large extent, the broader public was able to get some sense of how science actually works. The role of evidence, the reality of uncertainty, the difficulties in achieving consensus. And here we've seen we've had a wonderful tour through a particular area by Elizabeth of the scientific method at work. I don't know, though, whether her clarion call in relation to immunology is going to result in the dean redirecting any of his resources. I will leave that to them to fight it out. But let me simply conclude by adding my thanks very much to our inaugural lecturer, to Professor Pillay for her introduction, and to our dean for a lovely vote of thanks. Ladies and gentlemen, this brings us to the formal end of proceedings, but informally, please join us outside where you'll be able to have some refreshments and discuss the lecture or anything else you'd like to with our lecturer. Thank you very much for being here.
Look, I haven't done the haematology lecture, so
Single place. She doesn't agree with everything in this book.
No, I know.
yeah, because in India it was 3.5 hours ahead. So I don't want to make her wait.
What is the time difference?
3.5 hours.